Ladies and gentlemen, welcome to Stump the Chump. This is your chance to ask those tough questions that you couldn't get a straight answer to on the email list to Grant Ingersoll. And now our panelists, Lucene PMC members and committers, Simon Wilnauer, Uwe Schindler, Eric Hatcher, Robert Muir, and your host, Mark Miller. Mark, take it away, and let's see if we can stump the chump.
All right, welcome everybody to Stump the Chump. Basically, it's going to go like this. I'm going to call out whoever had the question. Hopefully they're going to come up and stand at the microphone so they can clarify or help the chump in his answering. And then the panelists are going to weigh in on whether he was stumped or not and maybe help answer the question if he couldn't answer it. And then we'll move on to the next question. All right, question one. Rather than butcher your name, you can see it up there. If this is your question, could you please come up? So the question is, I'll read it off first. I'd like to know how we can make field collapsing scale up to a collection of 600+ million documents with sub-second response time. What kind of architecture is required? Can the current implementation reach that goal? Grant?
Do you need to know all of the groups? Do you need to know the counts of all the groups, like the total number of groups, or do you just need to know like the top 10 groups at a time? I mean, top 10, top 20?
Well, we could work with only the top 10, but ideally would be...
Well, but you can could you page through the groups?
Yeah.
But do you need to know all of the counts all at once, like that there's 10,000 groups? Or would you be satisfied that you could just page through and people could just go iteratively
We could
deeper?
page through, but ideally would be to have the whole spectrum.
So the field collapsing stuff, sometimes known as result grouping, there's a lot of work underway on that. There is a patch that's committed on trunk. I don't know that it's been tested at 600+ million documents. I would say, though, that there's also actively a lot of work happening on that space right now. There's going to be a grouping module in Lucene and then in Solr. So, and I believe it will be able to do distributed, sharded grouping eventually. I don't know that we have that implementation right now. So the answer for what is the architecture required is you would need a sharded Solr system. But of course since it doesn't support sharding right now yet, you can't do that. So the second question is, no, you can't do that with the current implementation, but come back in 3 months, 6 months, or something like that. If you need, and that implementation, as I understand it, only will allow you to do the paging through the groups. It won't give you the total group count. If you, at that scale, the patch on Solr 236, that one can give you total group counts as I understand it, but I don't think it will scale. That's like a single node solution.
No, it doesn't scale up.
Yeah, it won't scale up to that. So that's pretty much just on a single node. So that's my assessment of results grouping.
Okay, thanks.
All right, so could we have the panel either thumbs up or thumbs down that answer? Quickly here.
All right.
All thumbs up. Is there anything the panel would like to add that Grant missed? Nope. All right.
We didn't say what I get if I answer all questions.
Oh, actually, those patches get committed to 3.x too. So.
Oh, have they been?
Oh, they're working on it, so you probably don't need to wait until 4.0 comes out.
So it'll maybe be in 3.2 or 3.3.
Yeah.
And the answer to the question you're all about to ask, when will 3.2 come out? That is actually the one question you can stump me on, because I don't know.
Well, you got an answer to the 4.0 question?
No, I don't have that answer either. All right, who's next?
All right, next
boy.
question, Trey.
Trey, come on.
This one's a little long. I'll try to read through it quick here. The question is, we have the need to pull back percentile values for a particular field for analytics based upon the results of a query. For example, let's say we are searching a bunch of jobs for Java engineer and want to see the breakdown of values in the salary field. What we really want is to be able to request the 10th, 25th, 50th, 75th, etc. percentile values. Today we can easily do multiple facet queries to bring back buckets of salaries for those jobs and then post-process the results based upon the counts to approximate the percentile values. The problems with this approach, however, is that we can only approximate the percentile values to the granularity of the closest bucket, and the sheer number of facets being requested can become enormous. Here's an example query. How would you suggest doing this using faceting, the terms component, or otherwise, where the percentile values are filtered down for the given search? Grant, any clarification you need there?
Let me think about this one. So how many do you have? It's an arbitrary number of ranges that you're looking for, like that you're currently doing the facet queries on?
Right. So right now we're going from $1,000 increments up to, I guess, 250,000. So it's 250 facet queries.
So I mean, there's the new numeric range faceting. Have you tried that yet? So where you can just say, you don't have to do facet.query. You can just say, start, end, and increment.
Right. But
then you still have to post-process.
Right. Yeah. So the goal is I want to be able to say what is the 25th percentile value?
Yeah.
What is the 50th percentile value?
So I've actually seen this one implemented before. I think there's a couple of pieces here. One that maybe out of the box works, and maybe talking to Ryan will help here. But the stats component will work with faceting and will give you things like mean and standard deviation and all of that kind of stuff. So that might help. The other thing I think at the end of the day that you have to do if you want this to be real low level is you'd have to implement a collector that as you're collecting the documents, you would probably have to hook into maybe something with a field cache too, so that you can actually calculate who's in the percentiles as you're getting back those documents for that search. I believe that's the way I've seen it implemented. Therefore as you're collecting documents, essentially that allows you to stop doing this post-processing technique, and it also allows you to not have to ask for all of these different things all the time, right? Like all the various ways that you're breaking things down. And boy, it was too long ago that I saw that implementation, because I feel like there's something else. I think what they used too was Commons Math from Apache has a percentile accumulator data structure in it. What they were doing was they were using that data structure as part of their collector. So they hooked into the low-level collector, and as they were seeing things go by, they just added them in, and it would automatically allow them to then ask that data structure for percentiles back. Okay? I think that's what I recall, and that's the answer I'm going to stick with. Does that work? I mean, obviously you have to implement something here. There's no out of the box. I do think the stats component, there has been some discussion around making that into a broader math component where you could ask for more mathematical expressions around this and do those kind of analytics. But otherwise, that's the only way you're going to get it low level and not have to do post-processing is the collector route. For those who aren't familiar, a collector is a really low level Lucene thing, whereby as Lucene is scoring, it's essentially a callback mechanism that then allows you to do things that you would otherwise have to do outside of after scoring. So it can save you some time and memory and all of those things. So that's my answer. Does that sound good?
All right, panel, up or down? Everyone up? Uwe, is that a thumbs down?
You have an objection?
Why not just do that 250,000 returns? Why do they need numbers?
So the goal is to have actual percentile values, not buckets. That's a workaround to approximate.
Okay. Objection overruled.
Anyone on the panel got anything to add?
I don't think so.
Panel stumped.
It would be actually, it would be good. It would be a good feature to have to go along with function queries. Is essentially this notion of aggregating function queries so that you can, do things like sums and all of that across multiple documents. I think that would be a useful addition. So, patch is welcome.
Uwe, was that a thumbs up or a thumbs down?
No, it's okay.
All right. All right, Simon Rosenthal, I think you may be disqualified from winning any money, but you're in for the question.
Yeah.
So how do you make a Boolean query with 100,000 OR clauses performant?
And I just want to clarify here, why would you want to do that is not an acceptable answer.
Buy really fast hardware? Define fast. I mean, is a 5% increase good enough for?
So something which returns within an acceptable time for interactive query.
All right.
Sub-second.
So I've had this discussion with Ted Dunning, and I really wish he was here. Maybe I can phone a friend. Because, so first off, I don't know that there's a way just out of the box in Lucene to do it, although, I think somewhat, there's a sense when you have that many clauses that after a while, the parts of the clauses that are of little value, they add very little to the score. And so if you could somehow have some heuristics up front to do that, so there's nothing native out of the box. I think that's all of a sudden going to make 100,000 queries give you, or 100,000 clauses give you sub-second response time. Although, yeah, well, I guess that's another question. Do you need scoring?
It would probably be implemented as a filter query, so...
Okay.
So if it's a filter query, though, that kind of implies that you're keeping this thing around for... is there a fixed number of these 100,000 ones?
No, it's variable.
It's any arbitrary.
Yeah,
some user is typing in 100,000 keywords and.
Some application is generating 100,000.
Yeah. So that'd be useful. A little bit more on the use case.
It's basically, and this is why I said, why do you want to do that? It's not an answer. It's basically a situation where, from an external source, we're getting document IDs which match a security constraint, which cannot be represented apparently in a sensible way.
Right. So it's like a late binding
Right.
model in a legal security area where, I shouldn't say legal, but a security area where you have really fine-grained security credentials, like almost like a per document or even within a document kind of credentials.
So are those all across one field?
It's all across one field, yeah.
Yeah. Does that help?
Yes.
Yeah, so you would just generate a bit set for it, but I think if the question is more generic of if you had that many just clauses and it's not even, you have a particular case where it's the number of fields. So I'm making it harder on myself, I guess, because I think you could just you could calculate a bit set. I almost wonder whether the finite state stuff that David was talking about this morning would be useful too, but I'm not an expert there. Like if you could build up a faster representation of all of the terms. Still be slow. But maybe it would be faster than the currently ORing them together. The other thing that I've seen done here is, and you can't just do this like with just one query, but so if you have a bunch of these, I think the thing that I've talked about with Ted is that essentially you have a machine learning algorithm that learns what are the actual fields and or query terms that give you the most benefit in the score, and then you can kind of essentially do a feature reduction on the overall 100,000 terms and feature reduce it down to a much smaller set of clauses which you can then run. So you may end up with just 1,000 terms, and of course 1,000 terms will be a lot faster than 100,000. But that's not trivial to implement, and that's not something that's out of the box. So other than that, the answer would be buy faster hardware and get SSDs and make sure everything's in memory all the time. And maybe Andre, well, he probably would say to use your his splitting areas. No? Do you have another one? All right, so.
There is a nice trick how to do it. Actually, it's already implemented as a patch or 2 Jira issues. It's a bitwise similarity or bitwise search. Okay. There are 2 patches for non-scoring and for scoring. So the trick is to represent the document IDs as hashes and then put them into a separate field which is constructed according to the requirements of that patch. These are simply bitmask terms that sit in that particular field. And then you represent your query also as a hash. And you do a matching on bitmask.
Is that just doc IDs or any arbitrary terms?
No, arbitrary terms. But okay. Simon's question was about doc IDs. So that's...
Okay. I guess I would half stumped. I don't know.
Yeah, the panel will decide that. Yeah. Thumbs up or thumbs down, panel?
All right. Well, you know, he's a Lucid employee, so he's ineligible from winning anyways.
All right. Anything on you guys want to add on the panel?
Just buy me a drink.
All right.
You guys good? Andre, yeah. Andre did a good job there. All right. Frasana? Another name butcher in the room. Recognize your question? Yep, right here. So suppose you have a large number of languages indexed in separate fields. How do I boost a query across those fields according to the user's ordered list of preferred languages? Maybe you can elaborate a little. We kind of had to write down with that question ourselves.
Actually a P at the beginning. My name is Prasanna, but that aside. So let's say you have a e-commerce search built using Solr, which is built for US, which is English only. Mm-hmm. Now you want to take it global. You want to, so you're adding metadata in French, German, Italian, so let's say. So the US one, it uses a Dismax handler. It works pretty well. Okay. So now what you want to do is essentially enable I18 and search on it, which is given a query, you want to search it across all the different languages in which you have metadata and return relevant results. But in addition, what you want to do in your Dismax is, if possible, based on GeoIP or if you have user preference info, in addition to the actual text scoring which happens on the different fields, give a secondary boost to the certain languages on which there was a match from the preferences. So let's say if the user prefers English, then Spanish, and you have documents which are returned which match in any of the different metadata, you want to give a boost based on his preference of language.
Yep, and so this is Solr, right?
Yes.
And the Dismax handler?
Yes.
So you have at query time, the user comes in, you look it up and you get that they have their languages. So do you also know, presumably you have then some boosting you want to apply to it, like, French gets boosted by 10 and then Spanish by 3 and on down the chain?
So because I use a Dismax, let's say I already match on 5 fields. One is title, one is description. So in my Dismax, all of these fields get different boosts.
But you have like title underscore French, title underscore
exactly.
English,
So
title underscore.
the boost for, I know only at query time that title underscore French should get a bigger boost than title underscore English.
Right.
Because it's a user preference.
So you can't you just pass in the those preferred languages to the dismax handler as part of the query. I mean, those are, if you put that in your defaults, so in your dismax handler, you have your default languages with their boost, so like, English across it. You can override those parameters at query time by passing in the names of the fields that you want to search against based on what the user's queries are. So it would be title underscore French, body underscore French.
So how exactly do you do the overriding? I don't really know how you do it.
So it's just I have to look at the wiki, but you just pass in the parameters. So that same syntax that you put in your Solr config that defines out the fields that you're going to search across with the boost for each field, you can pass in exactly that kind of string at query time, and then it will it'll override them and actually use your fields. Unless the only time it wouldn't is if you made them invariants in the config.
Right, but let's say the different boosts that you want to give to the different languages, you don't really want that determined at the client end.
Right, so you would have, in your application, you would have to know that, their first language gets boosted by 20, the second preference is boosted by 10. So, there's some concern there about whether the relevance would be, how you would deal with relevance across those languages, but...
Is there a way to get that boost also configured in Solr, as in, it's not, the user doesn't really say at query time overriding, English gets 20 boost, French gets 10 boost? Instead, all the user says is English gets a higher boost.
Well, no, this is in your application that you would do this. The user would just put in their query terms just like always, and you would go to your user profile, get their languages, and then presumably you've worked out during your build out of the system, what your boost preferences are going to be, and then you intersect that with the languages and then send that all in with the query.
Okay.
Otherwise, an alternative, if you wanted it all to be in config up front and you only had, a fixed number of languages, and maybe not, and you didn't allow too many combinations, maybe you could just have request handlers all configured for each of the primary languages and then have your back-off strategies. That's not as nice because you have more maintenance around it. But another option is, well, along that lines is you could have the primary languages as various options and then have just kind of one field that captures all of the languages. So you search the primary language independently and boost it higher and then throw everything else and then throw it all against the catch-all field. So what I would do probably is start with just passing in the overrides and see if you can get that reasonable results out of that, which I think you should be able to, because if you boost the primary language up high enough, that's the one that you're likely going to want the most results out of. So, Does that answer?
Yes.
Yeah, okay, so panel all at once now. No looking at the rest of the panel and seeing what they're doing. All thumbs up? All right. Anything to add? Robert, you can't get out of this not talking the entire time. How's his answer? How can you improve it?
Parse the query. Do the right thing. What's that? Oh, sorry, you can't hear me?
He just said you can do it in Lucene as well, so it's not just a Solr specific functionality.
Okay, next question. John Erickson? There he is. Okay, propose a fast, good solution for sorting on very large strings like URLs. Also on a large index, because it's pretty easy if the index is small. So I think he said 40 million documents.
Yeah, so I have about 40 million documents, and they go into the index unsorted, and I basically want to sort them all based on one field value that's a long string. So I ended up taking my original index, taking the 40 million string values, resorting, and then building up a second index so that I could have everything in my second index in the proper order, so that if things have the same relevancy score, they'll appear in the order that I want. So I was wondering if I basically had too much data for the field cache. So is there a way to sort data if you're sorting it?
Are you on only one node?
Yeah.
Well, I mean, part of it would be maybe you need to be sharded, but okay, but continue.
Okay, yeah, basically, ideally, I could do a sort on the original index instead of having to rebuild a second index. Is there any way that I can do that with the original index?
And how often are you updating the index?
Oh, it's a static index, so I basically rebuild it each time. So it's
How often do you rebuild it?
every couple of weeks.
Okay. And there's how many unique URLs?
Actually, it's
So it's like every document has a unique, that's like your doc ID?
Yeah, it's essentially a doc ID or.
So one thing that comes to mind is, since this is static and you're not having a lot of updates, you could essentially map all of your strings down to a numeric, and then numerics behave a lot better in terms of field cache, memory usage, and all that stuff. So then you're just sorting on numbers, maybe. Maybe that would work. Because, I mean, the big problem, that's probably not right. So let me think about this some more.
I remember what we were talking about before.
Yeah, the doc values.
Optimize the index.
Optimize the index.
Then the term orgs will be sorted already.
Right, so then you just go in document order, essentially. Yeah, so I guess I'm stumped, but yeah, I mean, no, I mean, what they're saying is that essentially you have, if you just optimize the index, then that field, all of the strings will be in sorted order already. So then you could just return, you could do sorting by doc ID. Is that what you're saying?
Yeah, well, basically you have each term as an ordinal, right? So if you optimize your index, your term dictionary will be sorted, right? So you only need to figure out the ordinal for a document. You don't need to load the string at all. Because you don't need to do a comparison. Since you're a static index, you optimize it once, and it's going to be just integers. Well, let's say you have the URL field, right?
You would have a separate field, a second field, one for your display purposes and then one for sorting purposes, right?
And then it's like let's say URL A is ordinal 0, and then it goes forth until the last URL, right? If you have an unoptimized index, you need to do string comparisons because the ordinal per segment could be different, right? But if it's optimized, it's just one big segment, and you can go from top to bottom and just assign, instead of loading the string, just assign the ordinal of the actual term, and then it's just an integer sort.
But the other thing, maybe just by sharding your index too, then you're splitting it across, and then you would have field caches that could fit in memory without having to do anything else. So trade-off between a single node solution or a sharded solution.
How big is that index?
40 million.
40 million?
That should be true.
Yeah.
What's the use case for sorting on URLs?
I've got a, do you know like Maven? It's like the Maven Central Repository. Yeah, it's the, I index and search all of the stuff in there. So if something comes back of an equal relevancy, I want things presented in order because users are used to seeing things with this particular data set.
So they know that the Lucene jar, and so they would see that, okay.
You can sort the whole thing. If you sort the whole thing up front before you index it, then you've got your secondary sorted there.
The difficulty with that is like I can't know all the values that I'm going to be sorting because I sort like classes inside of jar files and things, so I can't get those ordered beforehand. Although I guess I could dig into all of that, but it would really slow down indexing if I had to jump around with my...
Well, slowing down indexing may be the trade-off versus having slow search or not being able to do this requirement.
Okay, yeah. Well, my searches are fast since I like reorder the thing with the second index.
Okay.
Okay.
Yeah. Boy, I'm bombing.
All right, panel.
Okay, thanks.
Thumbs up, thumbs down. What do you got?
Those guys, I was stumped.
No. It's always Grant's answer. If Simon's answer was good, it doesn't count.
I didn't ask him for help. He just volunteered it.
Nothing to that.
Okay, yeah. This is a question from Simon, another non-winner, because he's on the panel. But in a geo...
Go to the next one.
All right.
No, that's a good one.
That's why we put it there. It is a good
Go to
one.
the next one. You can talk about it in the committer panel tomorrow.
John Erickson again. This one, all right, so you shouldn't get two, but I like this one too. We're going to do it. So how do you use the Lucene contrib dedupe filter on a non-optimized index and get the correct results? Because it doesn't work on a segmented index.
If it doesn't work, then there's a bug, isn't it?
How do you fix it? Why isn't it fixed? Why is it in trunk broken right now?
There's a Lucene contrib dedupe filter.
Yeah, that's what I said.
No, there is. Actually, I saw this on Monday. On a non-optimized index and get the correct results. Well, you submitted your issue, you convince a committer that they should work on it, and you get it fixed.
Okay. Yeah, my issue was I was using the duplicate filter, and so it would look for duplicates in each segment, but it wasn't looking across segments. So I was wondering if there.
Well, we already solved that you're going to optimize.
I think there is a solution in, I don't know if it's also in 3.1. What you could do is, in 4.0, there's a slow multi-reader wrapper, and that makes the index appear as one segment index to the index searcher, and then that filter would work.
But the name implies...
The name implies it's slow.
The other thing is, I'm trying to think if Solr's, no, this is at filter time. So you're deduping at query time. What are you deduping? The URLs again?
It was an older use case that I ran into, and I ran into that bug, and I was looking for functionality in the filter case in the class that would let me filter across segments, like sorting has capability to sort across the segments, but the filtering didn't. So I was wondering if there had been a way.
Well, I mean, the way to get the correct results is you should file a Jira unit, a Jira with the issue tracker, and hopefully, if you're really nice, submit a unit test that demonstrates it, and then nag all of us to work on it and get it fixed. And even ideally, if you really can, submit a patch that fixes it. And then you will have correct results.
There's already a bug.
So there's already a bug for this issue. So if you can submit a unit test, if there's not one for that, that would be good. Otherwise, yeah, I mean, it's broken, so.
I think the test in the contrib is using slow multi-reader. I think.
Yeah.
So, what was the ruling?
Yeah, thumbs up, thumbs down, guys. Thumbs up, huh? He didn't even come up with the slow multi-reader. That was Uwe. Come on.
Yeah, all right, submit a patch.
Fair enough. Submit a patch. No answer.
So the deduplication filter uses some kind of term, right, to figure out if it's a duplicate, or how does that work?
I believe so. Yeah.
So in Lucene 4 we have a reader tree, right? So we can basically cache based on the parent reader of a segment reader, and based on that we could fix that deduplication filter to use the parent reader or the top level reader of the segment reader as the key. Then it should work.
Okay.
Brian, you want to try to summarize this one to?
Sure. I think of it as kind of a composite document problem, or as I've called it in the mail, a document set. You have a set of smaller documents, and both the set and the smaller documents are interesting. In general, you want to be able to search and find the smaller documents or find the set, that's okay. But if I do an AND query, I want to find things that maybe one word's in one document, one word is in another. The way we're doing it right now is we are indexing everything twice. Once is the smaller documents and once is the big. We're doing hit highlighting too. Our index takes 6 days to build and is 680 gigabytes. So we would like to cut that in half and find a way to solve the problem without indexing things twice.
All right, let me, so you're essentially denormalizing the relationships, right? Let me just read here too. So when you do your search, you want to, if it matches in a small document, what do you return, both the small document and the large document, or just the parent document?
We return both.
Or does it not
We may mess
matter?
with the boost. It doesn't matter a lot.
And how many how many original documents?
10 million.
10 million. So then your denormalizing is making a lot more. Like how many million? 600 million, you said?
Oh, no. 10 million is the total number of small documents, and they are grouped.
But then how many total documents when you denormalize?
I'm not sure I understand the question.
So like when you said you indexed the larger document and the smaller documents?
Correct. So the total number of, you mean how many larger documents are there in effect? How many groups? I don't know offhand. It's probably on the order of 3 million.
Okay. So the new join stuff is in Solr trunk and would, I think, allow you to, my only concern, the join functionality allows you to say that there's relationships between documents, and then you can do a search and you would match in the child documents, and then you could get back the parent documents. What I'm not sure on functionality wise is whether it would also give you matches that occurred on a parent part of the document. So in other words, do you have it that you can split up, like there's a part of this group set, this set that is like a parent and child, or is just there's a whole bunch that are together?
It's just a top node that contains nothing, and it's just a grouping of the subdocuments, all the contents in the documents, not the parent.
How big is each group?
In terms of number of elements, or in terms of total size?
Number of elements, number of documents.
It ranges between about 2 and 550.
So you want to get back the parent documents only?
But so
they're coming in. New ones are coming in all the time.
But you know the whole group at one time?
Yes, a given group is not added to, if that's what you're asking.
But when you're indexing it, you know all 500?
Absolutely. Yes.
And so, but what are you retrieving back? Like, if there's a match against just one of those in the group, are you returning the whole group? Is that what you want to do, or you just
if there's
need
a match against one? I'm indifferent to whether it returns the individual document. It certainly needs to return the individual document that matched. It may also return the whole group. I don't care.
I guess the thing I'm missing is, let me just read the second clause. There are other searches in which form type is not limited, perform and queries which will match against the set. So in other words, contains a document that mentions peach and another document that matches pear. A search for peach and pear must return a match against the set. So, but I mean, why would that be an and query? I mean, wouldn't you just OR them together and you would get back both of those documents?
Or, yes, typo.
But so wouldn't it return those two documents in the set, and then you would, I mean, I guess I'm missing.
I do mean and, I'm sorry. Yeah, well, peach, what do I mean?
I mean, you would get back.
You want to know that they're both there.
Okay.
In the set.
Well, actually, it does, but you're not returning the set, so you just need to know. So in other words, if there's another set that contains just peach and then a third set that just contains just pear, you would not return any of those sets.
It's an and, yeah.
Well, so why do you need to? So then presumably you also have queries where you just search for peach and then you want to just return that one document. Mm-hmm. I mean, typically what people do, I think, is what you're doing is the denormalization, that you have this big document that contains all of the smaller documents and you would just return that one. In that case,
I think we've hit a time limit here. Panel have anything to add?
1 sec.
Time limit. We got three minutes to wrap up.
The other thing is clustering, maybe, or something like that would, I don't know, maybe that would help.
Maybe a custom version of and query. That's
write your own query.
between the different documents, whether they belong to a set.
Right, so you could have a collector, again, you could also do a collector at the low level that when you perhaps as you're seeing things coming along and you find one that's in a set, you would, so it's kind of a special case of the result grouping too, that might help. But no, that's...
The end. The panel,
Yeah.
thumbs up, thumbs down?
Thumbs down.
Anyone have a quick correction, answer, help?
Well, maybe I missed something, but Lucene 4 has a support
What's this Lucene 4? There's no such thing as Lucene 4.
Well, you was asking for a resolution for nested documents.
Nested documents.
So basically how it works is you index a group of documents and all belong to the same set, right? And Index Writer supports this now. They all also have the same delete key and all kinds of things. What you can do at search time is you can figure out efficiently to which group this document belongs to. Just by the first document of a group would be marked in a bit set, and based on what this document has a key, you can tell, okay, it's in set A.
And that's committed? You have to know the whole grouping up front when you're indexing, and you can't add to it. You have to delete and then re-add all of the documents.
Right.
All right, so nested documents, yeah, I would say I was not aware that was in. I had heard talk of it, but I didn't know that was actually in yet, so.
Just the index writer part.
The index writer part is committed.
But not the search part.
Right.
So then that doesn't work
because it was
either.
missing that part.
The join idea.
You like the join idea?
The document that represents the set, and then you're joining on the elements of the set.
Join would work.
Join would work.
Necessarily be fast currently, and you wouldn't get relevance.
I think denormalization though, or the big document and the small one, but you said that's not actually working for you though? I mean, currently you have this large document and a bunch of smaller ones. I mean, what doesn't work about that? I mean, you say it's crude, but doesn't it work?
The index is so large, takes so long to build, slows down the searches.
But how many total documents?
10 million.
And that takes you how long to build?
6 days.
There's something else wrong with your system. 10 million documents should not take 6 days to build.
Even with hit highlighting.
Well, hit highlighting is a runtime, query time thing. Term vectors. This is a perfect example.
Admittedly, yeah, okay.
No.
There's a flaw there. We're not using fast vector highlighting because right now this thing is sitting on a 700 meg SSD drive. We don't, and we don't want to double it to allow for
that should not.
space
I mean, unless you're doing some crazy things upstream, like a lot of processing, 10 million documents. I mean, half hour.
Anywhere between half a K and 50 megs, probably averaging out in the 10 to 20
Oh,
meg
so okay, so you have really big documents. I don't know, there's something still wrong in your indexing process there, would be my assessment, because I don't think that should take that long. I mean, I'm not going to say, I won't go to say 30 minutes or something like that, or 15 or whatever we've got Lucene 4 up to now on, but 6 days is too long. Okay. So.
Where are you getting the data from? Where are you getting the data from with your indexing?
What is the data?
Where is it in a database? Are you crawling?
Flat file system and database and flat file.
Yeah, I would do some profiling and/or analysis of why that's taking so long, and try to fix that.
Fair enough.
So.
Likely not the Lucene part that's taking a while.
Yeah. 10 million documents should be fast. Yeah.
Thank you.
Yep.
All right, I think we've hit our time limit, so I guess the panel is just going to get together real quick and determine the order. We do have time? Great, awesome. One more, Alex Lampert.
Scope search.
Oh, kind of a long one, but.
Why don't you read it?
Yeah, try to read. You want to summarize while he's reading?
So fast offers scope search, where I can search an XML document and ask questions like, you see a paragraph represented there. I can ask questions like, show me all sentences that have Steve Jobs and the company with ticker symbol Apple in the same sentence. So the important thing here is that it scopes the content to a particular context within the document.
Yeah, actually I'm familiar with scope search.
Okay.
So I believe the answer to this is two parts. The first part is you have to have analysis capabilities during indexing time such that you can index marker tokens or things, essentially the scope pieces that you want to search against. And this is one solution, I think. And so that they're in the index. And then you use maybe a little known feature in Lucene called the span query, which allows you to do position-based matching. So this is something you commonly do. Like if you want to only search within sentences, you could put in sentence boundary markers as tokens and then do position-based queries that say only search between boundaries. So I think that would probably be the primary way to do it.
Even if the boundaries, if there are like multiple sentence boundaries within a single document?
There's multiple, yeah, so like, I mean, in these cases, like if you wanted to just find within companies, so like the typical case is you want person is Steve Jobs and company is Apple together within the same document, right? But within those specific scopes, you can, I believe and I've seen prototypes built and helped build prototypes that you can do that with span queries plus this, technique of essentially with XML of indexing marker information into the indexes, kind of like special tokens that you then choose to ignore, that serve as the boundaries. The downside, of course, is all that position-based searching is more expensive. Although maybe getting faster in 4.0. Payloads, yeah, I mean, but a payload essentially acts as a marker in the thing. So, you can use a payload is essentially a byte array attached to a specific token at a specific position. So that again works like some type of marker token that allows you to then focus in. But the key really is probably that position-based querying plus some upfront analysis.
Cool. Thank you.
Panel, thumbs up, thumbs down. We got 4 up. Okay. Anything to add? Yes, no? All right. So, well, David makes a little announcement. The panel's going to huddle together for about 20 seconds and declare the first, second, third place. Third place, Jean-Sebastian, I promise not to butcher your name, but now I am. The field collapsing question, third place.
And in second place?
Second place is Brian with the document set querying question, just came up.
Brian, come on down. Second prize, a round of applause. And in first place for a $100 Amazon gift certificate, the winner is
John Erickson. He had the URL questions and the dedupe filter.
Congratulations! And thank you for playing Stump the Chump.